Welcome back to your Azure Cloud series. In today's episode, we are going to focus on cloud computing performance, a crucial aspect of delivering reliable and efficient services. Here, we'll cover KPIs. That stands for Key Performance Indicators. These are used to measure cloud system and explore strategies for optimizing application performance. So KPIs are important for that. So let's get started with this episode. Now, key performance indicators. Well, let's begin with the essential KPIs. That helps measure cloud system performance. There are many. We will only dive deep into the most common one. The first one is uptime and availability. Well, uptime measures the reliability of a cloud system or a service, often expressed as a percentage. Example you will see as 99.9% uptime or 99.9999 as well. So now you know what uptime means, and a lot of cloud platforms actually even brag about it. Sometimes they say that, hey, we offer 99.99% uptime. That means the downtime will be super minimal. Now, the high availability is essential for ensuring customer satisfaction and also maintaining service continuity. Cloud providers typically offer SLA, service level agreement, that guarantee specific uptime levels. So this is actually used to measure KPIs, key performance indicator. The next one is, how about latency? Organization can also measure the KPI according latency performance. So well, latency actually refers to the time it takes for a system to process a request and deliver data. Now, lower latency is crucial for real-time application like video streaming, online gaming, and financial transactions, where even a slight delay can impact user experience. For example, I don't know if you remember this, but this cloud gaming infrastructure, such as NVIDIA's GeForce Now or Xbox cloud services, are pretty popular these days, right? But who started all this? There was a product called Stadia by Google. Again, the technology was okay, the vision was great, but there was some limitation. A lot of people faced latency issues. And the result was the kind of a failure of that service. So Stadia actually died, but now GeForce Now plus your Xbox Live, they are doing pretty good. The next KPI indicator is throughput. So throughput actually measure the amount of data processed within a given period of time frame, reflecting system efficiency basically. A higher throughput indicates that the system can handle large workloads without slowing down, which is essential for data-intensive application. So remember, keep the speed and throughput separate. The throughput is like the raw power of the machine, how much data it can process. Now, the next one is cost efficiency, or you can also say cost effectiveness. Well, here cost efficiency tracks cloud spending in relation to the value provided. Optimizing resources or the use of resources to minimize waste helps organization to control cost while maintaining performance. This is especially important in case of pay-as-you-go cloud pricing model. So well, let's say if AWS allow you to store 1 terabyte of data for, let's say, $100, and Azure allows you to store 1 terabyte of data for $90, in that case, Azure is giving you more cost efficiency. What's next? Scalability. Well, yet another way to actually measure your KPIs. Scalability measures a system's availability to adjust resources based on demand. Well, cloud platforms ensure automatic scaling, allowing businesses to handle traffic spikes without over provisioning. So, which actually improves both performance and cost efficiency. So, there is a link with cost efficiency as well. The next one is error rates. Well, error rates represent the percentage of failed requests or operations within a system. A higher error rate indicates issues that need to be addressed to maintain system stability and reliability. Now, monitoring error rates help identify and resolve performance bottlenecks, optimizing cloud application performance. So, if the error rates are high, then you or maybe the cloud platform is not meeting up the KPIs, right? So, with error rates, you can also measure the performance. Now, let's explore strategies to optimize cloud application performance. So, the next point is autoscaling. We have dealt with this concept so many times. It's a very much core concept. So, let me repeat it again for you. Well, autoscaling automatically adjusts cloud resources based on demand, ensuring optimal performance without over provisioning or under provisioning resources. For example, during spikes or peak usage, additional servers are added to handle the load if you're talking about horizontal scaling, or the resource can be increased if you talk about vertical scaling. All this is done while the resource maintain the performance, especially now during the spikes in the load or the spikes in the request. Now the next one is load balancing. Well, load balancing, or you can say load balancing strategies, distribute incoming traffic across multiple server instances, preventing any single server from becoming the bottleneck or getting overwhelmed. This improves system responsiveness and ensure high availability by routing traffic if the server goes down to other servers. Well, the next one is CDN, Content Delivery Network. Well, CDNs is or it actually cache and deliver content from server located closer to the user, reducing the latency and improving load up times. Well, this is especially important for global application, ensuring faster performance regardless of user location. Think about Netflix. The movie you are watching could be watched by anyone from anywhere in the world. Well, if that movie is stored only in one location, then some users will still get a good performance. But what about the user sitting way far from the main server? Well, that user will see a lot of latency issues and buffering. So the CDN will make sure that the user is actually streaming the content or accessing the content, which is located as close as possible. Now, the next one is caching. Well, caching involves storing the frequently accessed data in memories for faster retrieval. By reducing the need to repeatedly query the main database at the backend, caching actually improves application response or speed and reduce database load. Common caching solutions include Azure Cache for, let's say, Radius and AWS Elasticache. Now, all these are functionalities which help you to take advantage of caching. Now, resource monitoring and optimization. Well, continuously monitoring resources or resource usage and performance metrics allow you or your organization to identify the bottlenecks and optimize the resource allocation in the future. Now, tools like Azure Monitor and AWS CloudWatch provide real-time insight to the system performance, enabling uh, sometimes reactive, but mostly proactive optimization. Now, the next one is, well, your codes. So, efficient code and architecture. This is where DevOps will actually come in handy. Writing optimized application code and designing cloud native architecture enhances performance and scalability. For example, using containers for microservices allows different component of an application to scale independently, improving both flexibility and efficiency. So this is where your microservice will come in handy. Now, in summary, measuring and optimizing cloud computing performance is essential for delivering reliable and efficient service. Now, key KPIs, like performance indicators, like uptime, latency, throughput, scalability, help assess system performance. This is how you determine, right, that if you are performing in a good way or not. It's kind of a benchmark. And from that point, you can only go worse or better. How will you determine that? Remember KPIs. Now, while strategies like auto-scaling, load balancing, CDN, and caching ensure optimal performance and cost efficiency. By monitoring performance metrics and designing an efficient architecture, businesses can provide a seamless user experience and maintain high availability of their services. So I hope it is clear now. Thank you for tuning to today's episode. See you in the next one. Take care and good luck with your cloud journey.